Okay, so we're working still with L'Hopital's rule. And remember that L'Hopital's rule says that if I take the limit as x goes to some value, f of x over g of x, if that is equal to some indeterminate form, give me an example of an indeterminate form. 0 over 0. What? What's another indeterminate? Infinity over infinity. What else? Not necessarily. I'm not sure that's one that goes with this. What are some other ones, though, that we started talking about on Wednesday? 0 to the 0, something to the infinity. Okay, so if all of that is true, then that means that that limit is actually equal to the limit as x goes to a of f prime of x over g prime of x. And remember, I'm going to say it again, that this has nothing to do with product rule. I'm sorry, with quotient rule. Okay, I'm not taking the derivative of this whole thing. I'm taking the derivative of the numerator separately from the derivative of the denominator. Okay, and that's a really big, important thing to remember. So I've just got a couple more. I want to do 2 more examples. I want you to do number 53, and then if there are any more journal questions, we can go over those. Okay. So number 24 is the limit as x goes to 0 from the positive side, so it's going to be a one-sided limit. But we talked last week about how that was okay, that one-sided limits work just as well with L'Hopital's rule as the other kind of limit. Sine x to the x. So when you are presented with a limit, what's the first thing that you do? You substitute in, okay? And if we substitute in, what are we going to get? What? 0 to the 0. Is that one of my indeterminate forms? Yeah. Okay, so if that's one of my indeterminate forms, then I can kind of sort of apply L'Hopital's rule, but I can really only directly apply L'Hopital's rule if I have 0 over 0 or infinity over infinity. So again, one of the other things that we do when we are presented with a limit is do some algebra, or we're going to expand that to do some manipulation. So when I have a situation where I've got something to the power, what I try to do is, instead of considering my function as f of x is sine x to the x, what am I going to take the limit of instead? No. How am I going to manipulate this? What am I going to do? We did it Wednesday when we had 1 to the infinity. What did we do? Yeah, we're going to take the natural log. So that instead of taking the limit of f of x, we're going to take the limit of the natural log of x. And then when I'm all done, I'm going to take e to whatever my limit is. Okay, and that's the really important part that you have to remember. Okay. So I'm actually going to do a different limit. That's the limit still as x goes to 0 from the positive, but now, like I said, I'm going to take the natural log of sine x to the x. And how does that help me? How does that get me to the point where I've got something over something so I can apply L'Hopital's rule? What can I do? Come on, Elf, what can I do? You've already done all of this. What do I do? What do our properties of logs say I can do? Sari. Yeah, I can move the x in front of the natural log. So that gives me the limit as x goes to 0 from the positive side of x times the natural log of sine x. Now, is that something over something? Not yet. So how do I need to rewrite it? Yeah, over 1 over x. That's just a standard old manipulation. We can do that. And now when I substitute in my limit, what do I get? I don't actually get 0 over 0. I get infinity over infinity. Because 1 over 0 gives me infinity. What's the sine of 0? 0. I take the natural log of 0, and what do I get? Actually, I get negative infinity. Okay, so now it's the indeterminate form that I can apply L'Hopital's rule to. So remember, it's still the limit as x goes to 0 from the positive side. And what do I get when I take the derivative of the numerator? One over sine x. It's 1 over whatever's inside times what? Times cosine x. That's good. We're there. And then Maggie, how about the denominator? That would be the integral, but I don't want to take the integral. I want to take the derivative. Sari, what's the derivative going to be? Yeah. Bless you. So that's screaming for some manipulation here, right? So what is the denominator what is the numerator kind of sorta? Yeah, but is it really tangent? What's tangent? Yeah, sine over cosine. So this is cotangent, but who knows what to do with cotangent? What it is. What else is cotangent? 1 over tangent. I like 1 over tangent because tangent makes me feel good. I know what to do with tangent. It makes me comfortable. And now I have some funky complex compound fraction. That again is just screaming to be simplified, right? You got it. Good job. And now I'm presented with a limit. And what do? I plug in. And if I plug in, what do I get? Which means I can do what? I can use L'Hopital's rule again because I'm using the strong form. I'm using theorem 5. So that means that again, I'm going to take my limit as x goes to 0 from the positive side. And what do I get for the numerator? Is the derivative. Good. And what do I get for the denominator? No. I think I've discovered what we're going to do on Monday. Yeah, what's the derivative of tangent? Yeah, Monday we're going to make sure we write down all of our derivative rules and all of our integral rules and all of our special things and get our lives all organized. So that we'll be all ready for the AP exam. So, once again, Okay, so once again, I am presented with a limit. And what's the first thing I do? No. Plug in. So if I plug in, what do I get? The numerator, you do not need a calculator. Don't make me come back there and get angry. What is this really? Over. So what's negative 2x if x is equal to 0? It's 0 over 1, exactly. Is that an acceptable answer? Yeah, because what's that really equal to? 0. I don't have a problem with 0. Am I done? No. Right. Because at the very beginning, I decided I was going to change and take the limit of the natural log of f of x. Now that I'm all done, what I really found here was that the limit as x goes to 0 from the positive side of the natural log of sine x to the x is equal to 0. But that's not the answer that I was looking for. What I really want is the limit as x goes to 0 from the positive side of sine x to the x, which I can rewrite as e to the natural log of sine x to the x. So that's going to give me e to the 0, which is equal to 1. Okay, you with me? All right, this just takes practice so that you're comfortable with it. All right, we're going to do one more problem. We're going to do number 45. So number 45 is what? Why don't you do this one? Not, then don't look. No, it was Sarah who was saying don't write the answer. No. case Zoe and Maddie want to look at this and they don't know how to do this problem. Goes to the 1/2, it would be a lot easier. All right, so we all got it? Okay. Okay, Rebecca, Zoe, you're all right in the back? Yes? Okay. Gianni, did you get that? Okay. All right. So I want to do one more before we do number 53. And if we end up doing number 53 on Monday, that's okay. I'd like to do journal problem number 17 because I think it's a little bit, it's a technique that we haven't practiced yet. Okay. So what are we supposed to do in number 17? Could somebody read me number 17? Why do we keep having 0 approaches to the positive side when we're dealing with natural log? Right. If you drew a graph of natural log, it looks like this, right? You can't take the natural log of a negative number. Okay, so we're always going to be approaching 0 from the positive side. Okay, so I think we're supposed to do something graphically first, but I think we're just going to solve it regularly. So what's the first thing you do when you come to a limit? Plug it in. So if you plug in, what do you get? I get, well, the x is going to be 0. And what's the natural log of x going to be as we approach 0 from the positive side? Negative infinity, right? So that's going to be an indeterminate form. Because like we've said, there's lots of different ways to get to infinity and 0. And you can't just assume that that's going to be equal to 0. Okay. So this is an indeterminate form, but it's not the right situation to be able to use L'Hopital's rule, right? For L'Hopital's rule, I need something divided by something else, and then that has to be equal to 0 over 0 or infinity over infinity. So this is a situation that we haven't come across before. But what we do in this situation is we let x be equal to 1 over h. And then we change the limit. And if x is going to be 1 over h, if x is approaching 0, what should h approach? 1 over 0, which is what? Infinity. And actually, it's going to be positive infinity because I'm approaching 0 from the positive side. Okay. So I'm going to rewrite my limit as h goes to positive infinity, and everywhere that I have an x, I'm going to put 1 over h. So I'm going to have 1 over h times the natural log of 1 over h. Which I can write as the limit as h goes to positive infinity of the natural log of 1 over h, right? So I've come to a limit. What do? Plug in. So the denominator is pretty easy because I get infinity. What about the numerator? What do I get? What do I get? Yeah, negative infinity actually. Because 1 over infinity gives me 0. 1 over infinity, 0. And the natural log of 0 is negative infinity, or at least the limit is the natural log. Okay? So this is an indeterminate form. Is it the right indeterminate form? Why not? It's infinity over infinity. I can apply L'Hopital's rule now, right? I have a numerator and a denominator, and I got infinity over infinity, or 0 over 0. So we'll use L'Hopital's rule. So I've still got the limit as h goes to positive infinity. So let's take the denominator first. What's the derivative of h going to be? 1. And how about the numerator? Well, it's actually going to be, remember, okay, if it was the natural log of u, okay, if I take the derivative of that, that's going to give me 1 over u times what? Du dx. Well, so it's going to be 1 over h, right? Okay. And then what's the derivative of 1 over h? Yeah. So you just got to remember, it's a little, you got to take your time. Okay, so this is going to give me limit h goes to positive infinity. This whole thing is going to become h times negative 1 over h squared. So that's going to give me the limit as h goes to positive infinity of what? Negative 1 over h, and I come to a limit, and what do? I Substitute in, and what's 1 over infinity? 0. Okay. Why don't you graph it? Okay. Excellent question. No, I don't, because I changed both x and the limit, and I was going to point that out. That if we change both x and the limit, and I didn't really introduce a new function like natural log, I just did a substitution. And it's like doing a substitution when we take an integral. If you change both everything inside the integral and change the limits, then you don't have to do anything at the end. It's all done for you. Okay, so that's a good point to remember, is that as long as we change the variable and the limit, whatever answer we get at the end is really the answer. And does it agree with what you get when you graph it? I believe that when you graph it, you get something that looks like this. And this is 1. Is that what you get? Okay. Then I think the bell's going to ring. So I'm going to stop here. I want to do, I think, number 19, because that, again, is a different technique. And then we're going to do, like I said, number 53 on Monday. And if we have some extra time, we'll work on organizing ourselves for the AP exam. But then let me tell you that now, since we will be in review mode, you will have homework every night. You will have a review packet every night that you are to do to help you remember things and help you learn things, and then we'll go over it during class. Okay? So just know that that is coming. Don't get senioritis. Okay? You all have the ability to do very well on this exam. And it would be nice if a bunch of people showed themselves and me the respect that we all deserve by holding on to the end and doing well on this exam. Thank you.